Hello, today's lesson is on 9.4 graphing quadratics in standard form. So today we're going to talk about how we're going to graph a quadratic that's not given to us in vertex form, but instead given to us in standard form. But before we get into that, let's take a look at this do now that I have on the presentation, because it'll review some things that we need to know to do today's lesson. So first things first, it says find the x-intercepts of the following functions. Hint, do you set x or y equal to 0? So it's important that it says x-intercepts here. If it said find the y-intercepts, that would be really easy, right? We got a quadratic here, so to find the y-intercepts, we make x equals 0. That cancels out our quadratic and our linear terms, and our y-intercepts are really just going to be that constant term sitting at the end of the function there. But it says to find the x-intercepts. So to find the x-intercepts, I make y0. So I get 0 equals 2x squared minus 5x plus 3. This means I have a quadratic with all three terms, so the first thing I'm going to try to do is AC method. My a times my c equals 6. My b is negative 5, so I have to see what adds up to negative 5. That's going to multiply to 6. That's going to be negative 3 and negative 2. So I'm going to take my middle term, replace it with negative 3 and negative 2, so 0 equals 2x squared minus 3x minus 2x plus 3. Group my first two terms, group my second two terms. My first two terms in x factors out, so I get x times 2x minus 3. My second two terms, a negative 1 cancels out, and I'm left with 2x minus 3. So that means my two factors are x minus 1 times 2x minus 3. Thanks to the zero product property, I know that if I take the two things that multiply to equal 0, I can set each of them equal to 0 separately. So I set x minus 1 equal to 0 and 2x minus 3 equal to 0. And my solutions wind up being x equal 1 and x equals 3 halves. Those are my solutions when I set y equal to 0. So that means those are in fact my x-intercepts if I were to graph that function. All right, now let's look at the next one. Next one, same thing. I want to find the x-intercepts, so I'm going to make y 0. So 0 equals x squared plus 10x minus 3. If I try to use AC method here, I'm going to get a times c equals negative 3, b equals 10. Now, there's nothing that's going to multiply to negative 3 that's going to add up to 10. So AC method is not going to work here, which means I either need to complete the square or use quadratic formula. I'm going to choose to complete the square because I see that this 10, my linear term 10 is even, so this should be pretty easy. So the first step, I'm going to add the 3 to the other side, so 3 equals x squared plus 10x. Half of 10 is 5, 5 squared is 25, so I'm going to need to add 25 to both sides. So I get 25 plus 3 is 28 on the left side. And on the right side, I'm going to be adding 25 at the end of this quadratic. X squared plus 10x plus 25 factored is x plus 5 squared. So now I'm going to square root both sides. I get positive and negative 2 root 7, right? Because 28 is 4 times 7 equals x plus 5. Last step, subtract 5 to the other side. I get x equals negative 5 plus or minus 2 root 7. So those numbers, negative 5 plus 2 root 7 and negative 5 minus 2 root 7, are going to be my x-intercepts for that function. Now, we can get into the logistics of actually graphing that, but that's, for another time. So the theoretical questions on the bottom here say, if we can find out the x-intercepts of these two functions, what's the other point that we need to graph them? So in a previous lesson, we talked about how, if you have 3 coordinates of a quadratic, that's typically enough to draw a good curve of that function, as long as one of those coordinates is the vertex. So we always really want to know that vertex, because that's going to tell us our exact turning point. It's going to make graphing a quadratic a lot easier. The next question says, are we able to find this point, the vertex, when the quadratic is in standard form? Now, the simple answer to that is yes. There is a way to figure it out. It's actually really easy. The long answer to that question is, well, let's actually take a look at this mathematically and figure out how we get to that simple way to solve the vertex. So that's what we're going to do in today's lesson. We're going to look at how we can take standard form of a quadratic and switch it into vertex form to find the vertex. Then in the next lesson, I'm going to show you guys how we can use that method to actually figure it out a lot quicker. Here we are. So switching from standard form to vertex form. So to switch from standard form to vertex form, we actually do the exact same thing that we do when we're completing the square to solve for x. So luckily, we already know how to do all of this. So here's an example. The steps are not written out, so we're going to write out the steps while we look through the example. So the first step in the example, I have f of x equals 2x squared plus 12x plus 19. So what happens is, again, we're pretending to complete the square. So the first thing is we take y and we make it 0. So the first step, make y equal to 0. Okay, that's simple enough. Now the next step, this is when we start completing the square. Our next step in completing the square is to move the constant to the other side of the equation. Other side. So as you can see in the example here, the 19 gets moved over to the other side of the equal sign, so I get negative 19. Now, in this specific example, we do have a leading coefficient for x squared, so I do need to factor out my a value. So 3, factor out a value. Right? So now that I have my a value factored out, I have x squared plus 6x. I want to make that into a perfect squared trinomial. So I'm going to take half of that value, 6. So 6 over 2 is 3. Square it. That equals 9. Oh, sorry, not third step. Fourth step. Fourth step, half b and square it. Then, as you know, we're going to add to both sides of the formula. So we're going to add that value to both sides. So 9 gets added inside the parentheses here, which means it's being multiplied to 2. So when I add it to the other side, I'm not going to add 9. I'm going to add 9 times 2. So I add negative 19 plus 2 times 9, which gives me negative 1. And then on the left side of my formula, once I've added that number that makes it a perfect square trinomial, I then factor my quadratic. So in this case, we factor the quadratic x squared plus 6x plus 9. I get x plus 3 squared, still with that 2 in the front, equal to negative 1. Now, this is the point where we'd start solving. So we'd divide by 2, we'd square root, we'd add 3. But in this case, we do not want to solve. We're not trying to solve for x here. We're trying to make it into vertex form. Well, as you can see, on the left side of my formula, I already have an a value times x plus an h value squared, but right now it's equal to a number. If we move that number over, so now the last step here is going to be move any number to, or should I say like back to opposite side. That's a terrible way of saying it. So basically what I mean by that is, we started by making y equal to 0. So what we want to do is we want to make, we want to create a situation where we're again equal to 0, because if it's again equal to 0, we can then change that 0 back to y. So that's what we're doing here. We're moving that negative 1 over to the other side so that it's equal to 0, and we can say y equals 2 times x plus 3 squared plus 1. Now this is in vertex form. Now I can say with confidence that the vertex here is negative 3, 1. Because if we were just given this formula, right off the bat, y equals 2 times x plus 3 quantity squared plus 1, we'd be able to look right at that based on the last lesson and say that the vertex is, in fact, negative 3, 1, and that's our goal here. Now, this method of switching to vertex form comes with more benefits. So, this part where I said, do not solve. Well, what if we did solve at this point? What if instead of switching it back to vertex form, I now take this and I solve for x? Now, in this case, when I go to solve for x, I'm going to get a square root of negative, so it's going to be imaginary. But if that wasn't the case, if I didn't get an imaginary number here, if I, got to this point right here, if I got to this point and I said, now I can break this equation into two. I can go here, solve for the vertex, or I could keep solving and solve for my x-intercepts. So by doing this completing the square method, not only can I solve for the vertex, I can also solve for the x-intercept, and I also know the y-intercept because it's my c value of my quadratic that they originally gave me. So now I have a vertex, I have both x-intercepts, and I have the y-intercept, which based on my axis of symmetry, which is x equals negative 3 here, I can find 2 points with that y-intercept on my graph. So basically, just from using completing the square on a standard form equation, I can get 5 coordinates of my quadratic graph. So like I usually say, none of this really is that easy until you try an example on your own. So let's take a look at this first one. F of x equals x squared minus 4x plus 4. So as we were talking about, we're going to basically just pretend to complete the square. So the first thing I'm going to have to do is make y 0. 0 equals x squared minus 4x plus 4. So I'm pretending to complete the square here. So I'm going to move my constant over. So I subtract this 4 to the other side. So negative 4 equals x squared minus 4x. I don't have an a value, so I don't need to factor that out. Take half of my b value, negative 2. Negative 2 squared is 4. So that means I'm adding 4 to both sides, which actually negative 4 plus that 4 is going to give me 0 on the left side of my equation, and I'm going to wind up with x squared minus 4x plus 4, which we already had up here. But I guess that just means that this was already a perfect square trinomial. Well, at least now we have evidence that it is a perfect square trinomial. Now I'm going to factor it. I get x minus 2 all squared equal to 0. So I don't have anything to move over. It's already equal to 0, so now I can switch my f of x back in. I get f of x equals x minus 2 squared, which means my vertex, based on this now being in vertex form, is positive 2, 0. Right? That's 0 because there's nothing after the x squared. Cool. All right. I switched out 4 for 2 because number 2 on your worksheet was the exact same example we just did, to prove how to do it. So I figured that was kind of just a waste of everyone's time to do that question again. So let's look at this one. F of x equals negative 3x squared plus 12x minus 8. Again, we're pretending to complete the square. First step, switch out f of x for 0. 0 equals negative 3x squared minus 12x minus 8. Sorry, it's a bad 8. So we're pretending to complete the square, add 8 to the other side, so 8 equals negative 3x squared minus 12x. Here I do have an a value in front of my x squared, so I'm going to have to factor that out. Factor out negative 3, get x squared plus 4x equals 8. Now I got to take half of my b value. Half of 4 is 2. 2 squared is 4. So I should be adding 4 in my parentheses. So I'm adding 4 in my parentheses, which means I'm going to actually be adding negative 12 to the other side because I have negative 3 being multiplied to, so this negative 3 is being multiplied to that 4 that I just put into the parentheses. That multiplies to negative 12, so I'm really adding negative 12 to the right side of my equation, so I have to add negative 12 to the left side. So 8 plus negative 12 gives me negative 4. So I wind up with negative 4 equals equals negative 3. Now it's time to factor x squared plus 4x plus 4. That should equal x plus 2 squared, right? Because it's always going to be whatever was half of my b term earlier. Last step, got to set it equal to 0, so I'm going to wind up moving this negative 4 over. So I wind up with f of x equals negative 3 times x plus 2 squared. Move that 4 over plus 4. Now this is looking more like the vertex form we're used to. So we look at this, we say, all right, I can tell by the equation that my x value is going to be negative 2, and my y value is going to be positive 4. My vertex is negative 2, positive 4, and just as a review, this negative 3 out front, the negative tells me I'm flipped over the x-axis. The 3 tells me it's a skinnier graph, right? It's growing quicker, so the graph gets narrower than normal. Okay, so now what I want you to do is pause the video, give this question a try, and, practice what you just learned in the video, and I'll give you 5 seconds and I'll come back with the answer. Okay, I'm back. Let's talk about this question. So we're trying to switch to vertex form, which means I'm going to pretend to complete the square. So I'm going to switch f of x to 0. 0 equals x squared plus 6x plus 8. Got to get this 8 out of the way, so I subtract it to the other side. Negative 8 equals x squared plus 6x. Now I have a perfect setup to create a perfect square trinomial. Half of 6 is 3. 3 squared is 9, so I have to add 9 to both sides. Negative 8 plus 9 equals x squared plus 6x plus 9. Negative 8 plus 9 is 1. X squared plus 6x plus 9 factors to x plus 3 times x plus 3, which is x plus 3 squared. Again, you might get the temptation here to go, oh, now I just square root both sides and subtract 3 so I can solve for x. But we're not trying to solve for x. We're trying to put it in vertex form. So instead of having the temptation to do that, have the temptation to move that 1 back over. So move it over so I have room to put my f of x back in. F of x equals x plus 3 squared minus 1, which means I have a horizontal shift left 3, a vertical shift down 1, meaning my vertex is at negative 3, negative 1. So at this point in your packet for today, you're going to get to this point where it says, is there an alternate way to switch standard form to vertex form? Going over another way to do it is just going to be too much work for today, so in the next lesson I will post another video talking about this alternate way to do it. I think you guys are going to like it, but there's no use in using a formula that you don't understand, which is why we have to talk about where that formula comes from before we use it. Okay, so finally we're going to put it all together for today's lesson on how we're going to graph a function. So this question tells us let's graph f of x equals negative x plus 6 minus 8 without using a graphing calculator. So it gives us a few steps. We don't really need to read through the steps. I'm going to just go through them. So I have f of x equals negative x squared plus 6x minus 8. The key piece of information we get directly from this standard form equation is that negative 8 is my y-intercept. So I go down to 1, 2, 3, 4, 5, 6, 7, 8. That's my y-intercept right there. We also see that this is negative, which means it's a negative parabola. It's going to go down. And that's really all we see from standard form. So now we want to solve for more things, so we want to put it in vertex form. So let's take our function and switch out f of x for 0. 0 equals negative x squared plus 6x minus 8. So first I got to get that negative 8 out of the way. I move it over. 8 equals negative x squared plus 6x. I don't want anything in front of my x squared, so I need to factor out that negative 1. So 8 equals negative 1 times x squared plus 6x. Take half of my linear term as 3. 3 squared is 9. So I'm going to be adding 9 in the parentheses, x squared plus 6x plus 9. And if I'm adding 9 in the parentheses are being multiplied by -1. I'm going to be adding -9 to 8 to give me a -1 out there. So I get -1 equals -1 times x plus 6 plus x squared plus 6x plus 9 factors to x plus 3 times x plus 3. So that's x plus 3 squared. And now this is what I was talking about earlier, is at this point we can actually break this into two parts. So my first part I'm going to break it into is switching it to vertex form. So that means I'm going to move this -1 back over. I'm going to get f of x equals -1 times x plus 3 squared plus 1, right? Because I'm adding 1 over, plus 1. And this part tells me my vertex. My vertex here is going to be -3, positive 1. -3, positive 1. So I'm going to plot that point. -3, positive 1. It's right there. That is my vertex, which also tells me my axis of symmetry is at x equals -3. It's nice to know my axis of symmetry because I see this y-intercept over here. This y-intercept is 3 points away to the right, which means I should also have a coordinate 3 points away to the left. So now I have another coordinate, but I can also, right, at this point, I split this equation into one part to get my vertex, but now I can also split in another point to get my x-intercepts. To get my x-intercepts, now that I've done most of completing the square, I just need to solve for x now. So I get -1 equals -1 times x plus 3 squared. So first step, divide both sides by -1. So I get 1 equals x plus 3 all squared. Square root both sides. I get positive and -1 equals x plus 3. Last step, subtract 3. X equals -3 plus 1 is -2. -3 minus 1 is -4. So x equals -2, -4. Those are my two y-intercepts. I have a not y-intercepts. Those are my two x-intercepts. So I have an x-intercept at -2, and -4. So now I just found 5 coordinates by simply finding my y-intercept in the original formula and then completing the square to get both vertex form and my x-intercepts. And now I have a pretty confident quadratic graph for -x squared plus 6x minus 8. Okay, so that's it for today's lesson. We're going to spend the next at least one more day, if not 2 more days, practicing this. And then in the next lesson, I'll show you a bit of a simpler method to find the vertex from standard form.